formula of phenol is C6H5OH. This is the molecular formula and structure of phenol. We are going to discuss about the preparation of phenol. Preparation of phenol. From aryl diazonium salt. Here benzene diazonium chloride. Benzene diazonium chloride, when you react with heat in the presence of acidic medium, to get phenol plus N2 plus HCl. Here benzene diazonium chloride, when you react with heat in the presence of acidic medium to gives phenol. Coming to the another process, and this reaction proceeds via aromatic unimolecular nucleophilic substitution reaction. This reaction proceeds via aromatic unimolecular nucleophilic substitution reaction. Now another method. The second one is hydrolysis of aryl alcohols, aryl halides. Hydrolysis of aryl halides. Here the chlorobenzene, when we react with sodium hydroxide in the presence of 350 degrees centigrade to gives alcohol, phenol. Here this reaction proceeds via aromatic nucleophilic bimolecular substitution reaction. This reaction proceeds via aromatic bimolecular nucleophilic substitution reaction. Now the reaction is like that. Here chlorobenzene, when we react with sodium hydroxide in the presence of 300 to 350 degrees centigrade to gives phenol. And this reaction proceeds via aromatic bimolecular nucleophilic substitution reaction, and this process is also called Dawes process. The preparation of phenol from chlorobenzene in the presence of sodium hydroxide and through 350 degrees centigrade to gives phenol, and this process is called Dawes process. The preparation of phenol from this process is called Dawes process. Now we will see another method. We will see from alkali fusion of aryl sulfonic acid. Once again I am explaining, friends. Here today we are going to discuss about the preparation of phenols and chemical properties of phenols. Here in this, the first method is from aryl diazonium salt. Here benzene diazonium chloride, when you react with heat in the presence of acidic medium, produce phenol, and this reaction proceeds via aromatic unimolecular nucleophilic substitution reaction. Hydrolysis of aryl halides. Second one, And heralds of aryl halides proceeds via aromatic bimolecular nucleophilic substitution reaction. And the chlorobenzene reacts with sodium hydroxide in the presence of 350 degrees centigrade to give phenol. And this reaction proceeds via aromatic bimolecular nucleophilic substitution reaction. And the preparation of phenol from this method is known as Dow's process or Dow's method. Okay. Third one is alkali fusion of aryl sulfonic acid. Alkali fusion of aryl sulfonic acid. The third one is alkali fusion of aryl sulfonic acid. Here in this benzene sulfonic acid, when you react with base in the presence of 300 degrees centigrade to give sodium sulfaphenol ion, and then sodium sulfaphenol ion when you react with acidic medium to give phenol. Here benzene sulfonic acid when we react with strong base, that is sodium hydroxide, in the presence of 350 degrees centigrade at 300 degrees centigrade to give sodium salt of phenoxide ion. Sodium salt of phenoxide ion. This sodium salt of phenoxide ion when we react with acidic medium to give phenol. The fourth one is from decarboxylation of phenolic acid. From decarboxylation of phenolic acid. Decarboxylation of phenolic acid. Acids. Here decarboxylation means the removal of acid group is called decarboxylation, or the removal of carboxylic functional group is called decarboxylation. Here we will see one example here. This is phenolic acid. When you react this phenolic acid with sodium hydroxide and calcium oxide mixture in the presence of heat to give phenol. Here by losing one carbon dioxide to give phenol. Here the phenolic acid when react the sodium hydroxide and calcium oxide mixture with heat to give phenol. Okay. And the last one is from cumin. See here again the phenolic acid when react with sodium hydroxide and calcium oxide mixture in the presence of heat to give phenol by losing one carbon dioxide to give phenol. This is the preparation method of phenol from decarboxylation of phenolic acid. Now see last one from cumin. The fifth one, preparation of phenol from cumin. Here is cumin when we react with oxygen in the presence of heat, that is 32 degrees centigrade, to give CH3 cumin hydrogen peroxide. Then this cumin hydrogen peroxide when you react with acidic medium to give phenol and acetone. See here cumin, when we react with oxygen in the presence of heat, that is 132 degrees centigrade, to give cumin hydrogen peroxide. Cumin hydrogen peroxide. And again, this hydrogen peroxide, when you react with acidic vinegar, to give phenol and acetone. These are the preparation methods of phenol. And now we will discuss physical and chemical properties of phenol. Physical properties of phenol. Here, generally, boiling point and solubility of phenol is greater than any salt. Solubility of phenol is greater than any salt. Here we will see one example. OH, anisole. This is phenol. Anisole. So here the molecular weight of phenol is less than anisole. Here the phenol OH. Here H is substituted by methyl groups. That's what here the methyl group. The molecular weight of anisole is greater than phenol, but the melting point of anisole, melting point and boiling point and solubility. Melting point, MP, BP and solubility of the anisole is less than phenol, because phenol possess hydrogen bond. As phenol contains hydrogen bond, this molecule possesses high melting point, boiling point and solubility. But the molecular weight of anisole is greater than phenol, even though due to hydrogen bond, the phenols exhibits high melting point, boiling point and solubility. Now, coming to the chemical properties. Chemical properties These, the first one is the acidic character and salt formation. The first one is acidic character and salt formation. Here the phenol on dissociation to gives phenoxide ion. Lossing on a proton to gives phenoxide ion. This phenoxide ion is more stable than phenol. Because the phenoxide ion, oxygen contains electron surplus, and this electron surplus can donate electrons to the benzene ring and gives resonance structures. That's what the phenoxide ion is more stable than phenol. This phenoxide ion, when we react with sodium metal, to gives sodium salt of phenoxide ion. And same phenol, when you react with aqueous sodium hydroxide, to give sodium salt of phenoxide ion and water. And this phenol is capable to forming salts only with strong bases like sodium hydroxide and sodium amide, etc. etc. Now we will see use sodium salt of phenoxide ion, sodium salt of phenoxide ion, and same phenol react with aqueous NaOH. Here the phenol, same phenol will react with sodium hydroxide strong base to give sodium salt of phenoxide ions. Here this water molecule here. Actually, the phenol is capable to form salts only with strong bases like sodium hydroxide and sodium amide, etc. That's what here. This is phenols can't give salts or can't give product with weak base like sodium bicarbonate, etc. That's what the phenol gives only salt with only strong bases like aqueous NaOH or sodium amides. Okay. The second reaction is ether formation. Here, the second reaction is ether formation. The phenol when react with methyl iodide in the presence of base, strong base, or dimethyl sulfoxide in the presence of strong base, or diazomethane with ether to give anisole or ether. Phenol when you react with methyl iodide in the presence of sodium hydroxide or methyl sulfoxide in the presence of sodium hydroxide or diazomethane in the presence of ether, diethyl ether to give ether. This is the ether formation. Phenol when you react with methyl iodide in the presence of strong base or dimethyl sulfoxide in the presence of strong base, diazomethane in the presence of diethyl ether to give ether. So this is the ether formation. Now we will see reaction. Here the phenol ether formation. Ether formation. Here phenol react with methyl iodide in the presence of NaOH. The presence of methyl iodide when you react with methyl iodide in the presence of strong base to give anisole. It is a anisole, and or same phenol when you react with dimethyl sulfoxide in the presence of strong base to give anisole. Okay. Or same phenol react with diazomethane in the presence of diethyl ether to give ether or anisole. This is the anisole. This is also example for the alkyl aryl ether. Alkyl aryl ether. Alkyl aryl ether. Now coming to the third chemical property, that is esterification. The third one is esterification. Esterification. Here, phenol when we react with acetic anhydride in the presence of pyridine to give phenyl acetate. To use phenyl acetate. Phenol and react with acetic anhydride AC2O in the presence of pyridine to use phenyl acetate. To use phenyl acetate. To use phenyl acetate. Here the phenol, when you react with acetic anhydride, that is CH3 CO O CO CH3. This is acetic anhydride. Acetic anhydride. That phenol will react with acetic anhydride in the presence of pyridine to give phenyl acetate. This is the formation of ester is called esterification. Here the formula of esters are COO R dash or COO R dash is called ester. So the formation of this ester is called esterification. Okay. We'll see one reaction, that is benzoylation. Benzoylation. The fourth one is benzoylation. Benzoylation. Here phenol, when we react with benzoyl chloride, here phenol, when we react with benzoyl chloride in the presence of strong base to give phenyl benzoate. To use phenyl benzoate. Use phenyl benzoate. Use phenyl benzoate. And this reaction is also called Shorten-Bowman reaction. This reaction, the name of this reaction is Shorten-Bowman reaction. Shorten-Bowman reaction. Shorten-Bowman reaction. Here the phenol, when you react with benzoyl chloride in the presence of strong base to give phenyl acetate, phenyl benzoate, and the name of this reaction is called Shorten-Bowman reaction. Now we'll discuss the electrophilic substitution in next class. Okay, we will meet again tomorrow. Bye.